can say the surrounding countries' names?
Yeah, on the north side we have
Kazakhstan.
Kyrgyzstan.
Sorry?
Kyrgyzstan. Yeah. And then Turkmenistan, Tajikistan, and Afghanistan.
Afghanistan.
Yeah.
Okay. So you are Afghanistan is south of your country.
Yeah.
Okay. So you are north of. All right. Good. Okay. I know where is France and India, so we don't need to. You should be Alessandro Maran, right?
Sorry for my late.
No, it's not late. Exact time. Which country are you from?
I'm from Venice, Italy.
Italy,
Yeah.
Venice.
Yeah, but I studied my bachelor in Milan, and now I'm doing my master in Copenhagen.
Oh, good.
So yeah.
Okay.
I like to switch countries.
Oh, good. Did you?
Yeah.
Okay. So Venice is very beautiful city, right?
Yeah. Very crowded, but
Crowded. Tourist?
Yeah.
Okay. Is Youngi coming? You did not see? Youngi and Sunjo, the last two, you cannot read this. This is Korean characters, right? Kwon Sunjo is there. Right? He is helping me for making video. And Kim Young-gi, another student. Both of them are under my supervision, PhD student. But he is missing because he was in China together with me until yesterday. We had a tough schedule. Maybe sleeping still, right? Let's see then. Can you explain about yourself?
My name is Tahir Abbas Juhat. I'm from Pakistan.
New student. Who are the new students to here? First semester, right? Okay. Second semester. All right, let me start. So this is a knowledge-based design system. Actually, I teach this one for a long time, more than 10 years. But recently, I did not offer this one. So last class was 4 years ago. But this semester, I tried to do it again because of several reasons. One of them is TensorFlow, the famous AI toolkit. And so that I want to learn about this myself too. And second one is I'm preparing for my retirement within 3 years. So I want to keep my lecture as a video tape. That's why I'm starting. Okay. So today I will show you some goals of this class. It is already written in syllabus that is uploaded in the ERP system, course class system. And I'll show you some textbooks. Oh, I missed to bring them. But you can see them images. And then there are 2 TAs, but they are missing today. All missing. But we'll see one of them on Wednesday. The other one is in Busan City for experimental work. He will come back next week. And then operation of this class, I try to separate out, trying to minimize my lecturing. So I hope you can have a class presentation together with me. So every class will be divided into three parts. So 1/3 will be covered myself, another 1/3 covered by yourself, one of you, and the other one will be discussion session. It was we did similar format for 1 year, so 2 semesters before. It was good for me. Anyway, we'll see. Right. Then class schedule will be shown. And then I prepared a slide for why I'm trying to include TensorFlow to this class. So I myself also want to clean up my ideas. So there is a separate presentation for this. So goal of this class is I hope you understand or learn about terminologies of knowledge-based design systems. To doing good, you need to understand what is engineering design. You may already know what is engineering design, but we'll see more deeper inside what is design in this class. And then you also need to know about what is knowledge and how can we represent a knowledge piece into the computer system. Right? Then we can use knowledge-based system. It is very similar to it is new, probably new to you, right? You can say database system. What is database system? You already know, right? It is based on data. Right? Database system. Similarly, knowledge-based system is based on knowledge. Right? So collection of knowledge, collection of data. Collection of data is a database, right? So collection of knowledge is knowledge base. Then you can do something with knowledge base. Simple, right? Simple. Knowledge based system. And we will trying to apply that knowledge to the engineering design. That is knowledge based design system. But this time I'm trying to use TensorFlow. TensorFlow is a kind of neural network. And in the textbook is written a long time ago. Right? I could not find the better version or new version. Probably because I'm not working off. Anyway, but neural network is a portion of that textbook. It's already covered in 17 years ago. But it's one small chapter or section, neural network. But now, because of the Google and especially in Korea, AlphaGo gives a new age to the neural network. But basically, I understand that because of the big data, the big data gives a new life to the neural network. Neural network, it does not have big changes from more than 10 years ago. Nowadays, there are more research on neural network again. So maybe within several years, there may be a new kind of neural network. But still, we are using old neural network. But the new thing is a big data. Because of the big data, neural network gets boom again. Right? Boom again. So, but still, Google is research and other big giant IT companies and research institutes are working on neural network technology, so there can be an advance in the near future. Yes. And then we will try to apply them to the term project. Any questions? You can raise any time, right? If you have something to understand. So because I did this class probably less than 10 times, about 10 times, so there are slides prepared. So that will be provided to you, PowerPoint files. Especially if you want to, if you need to have your your class presentation, you need to have a slide set. So I'll provide the old one. Then you can update and present in the class. That is my wish, right? And this is the main text. They are coming from Australia and specialized in architect, building design, architectural department. But it is old book, right? 17 years old. Still I'm using. It's a good book still. I could not find a replacement. One new one, still 7 years ago. He's from United States. I cannot remember his university. He's a professor. They both are coming from university. And it is a little bit more new terminology like computational intelligence and design and manufacturing. The title of the book is very good for me. The content was not so good for me. So this one is still better for me. But anyway, we'll see. So main coverage will be the first book. Right? And then we will add new things like a TensorFlow and neural net. So this is the book. You don't need to buy this book, but well, it may be better to have, but you don't need to. Actually, this person, John Giro, is a famous person in AI in design, engineering design. He's still operating his own conference every year. He's old, probably older than me. So this is the contents of the book. So it is made of 8 chapters. We will cover up to 4 and then jump to the 8. And this one will be summarized in short, because these are for application. But because of that, application is 17 years old, more than 17 years old, so it is not up to date. But these are methodology and theory, so it is still working. Right? So I will cover up to 4 and then jump into. Right. So introduction and model. What can be model? Model can be an equation or computational models or others. Model is very general terminology. And then representation. Representation, how can we represent design and knowledge into the computer? I said that as similar to data, we should put many knowledge pieces into the data to make a knowledge base. Right? But how can you represent a design into a computer? One sample is CAD, computer-aided design. Have you experience using any CAD system? CAD system, CATIA, right. Siemens or SolidWorks. You don't have any chance. Right. So using a CAD system, we represent a design into the CAD system computer, right? So there is a sample. But that is only a part of design, not all of them. I can say the geometry, shape of the design is into the computer. But anyway, that is a kind of representation of design. Right? So we will learn how to represent knowledge, especially design knowledge, into the computer. And then after that, after representing and storing the knowledge and design into the computer, we can operate them, right? We can use them. There is a reasoning. Reasoning is trying to provide solution to any problem, right? Reasoning, in general terminology. Right? So, using the design model inside the computer, using the knowledge pieces inside the computer already stored knowledge base, we can do some reasoning, right? So they are saying reasoning in design. Right? Easy, right? Still easy. And then among them, there are more details: interpretation of design, producing the design, and design process. So interpretation. How much it will cost, how strong it is, right? And weight. When I drop this one, it will be breaking or not? That kind of thing we are learning in mechanical engineering, right? There is interpretation of design. I had a new idea of next generation smartphone. Right? Only in my head, right? There's concept. How can I produce them? How can I make them? There is engineer's work, right? Engineer's work. But can it be nice? I don't know yet, right? I just have an idea. So we need to have an interpretation of that design. Cost, weight, structure, safety, performances, like this one, right? So we are learning in mechanical engineering to do that kind of things. Another one is producing design itself. That is more tough. How can you produce a new design, new smartphone for the next year? Right? Everybody can do that. Everybody can do that. But it should be nice, right? It should be nice. But anyway, these two processes in reverse way. If there is a design already, then I can interpret them. Right? But how can you produce that design first time? So it's a problem, egg and chicken problem, something. Right? It's rotating, iterating each other. But usually we learn more about interpretation in our mechanical engineering or whole engineering studies rather than producing one. But this class is more about producing one. Right? So you need a clever idea. That's why we are saying artificial intelligence here, knowledge-based system. I hope, right? And then the process itself is made of activities, working, activities, action, making design, right? What can I do at the beginning? What can I do? Should I prepare my desk first, or computer first, or money first, or helping personnel first, or office? So there is a process of designing, right? So it is made of sequence of activities, sequence of small activities. Usually the whole process can be divided into small pieces, small activities, can be a network, but there is a sequence. So time is important for that. The other ones, still time is important, but there is no important sequence in there. Interpretation and producing can be happen to my idea sometime in the middle of my running or sleeping, right? Hitting my head, right? Sometimes idea is coming, right? There is no sequence. There is no mandatory sequence. But design process need to have some sequences. All right. And then finally, there is a final chapter on learning and creativity in design system. So learning, you are learning the class now, right? You are as a student, right? But they are saying that creativity and learning is very similar, resemble each other. Do you agree with this? Do you agree on this? Creativity and learning is very similar. We'll see that. In design system, it is always come with the design system, but you can separate out design. This general terminology, right? So learning and creativity process, producing design is interpreted. Question? No. This is second book, but I may not use this one. But if there is a time, we may cover some of them. For time management, right? So, rule-based approach. Rule. So, I started from knowledge base, and then I explained the database, right? And then it comes to rule base. Right? So, rule is a kind of knowledge, a kind of knowledge. So, there was a expert system. Have you heard about expert system, anybody? No. It was popular 20 years ago. Very popular. As much as TensorFlow now. Rule is say something like, if something A, then B. Right. That is simple rule. Okay. Simple. So it can. There is a variation, and then otherwise, or there can be more. If and if, also, and so this is computation is coming. But anyway, the simplest one is if something, then B. Right? That is the simplest form of rule. And then we say this is a kind of knowledge. So we can collect many rules. Many rules. Can be coming from, say, law book or regulations. Right? They may have a very similar patterns in there. If you drive more than 100 kilometers, then you should get penalty. Right? That kind of thing. Right? But in engineering, we have different things. Right? If stress level is over 100, then you should increase the thickness or change the material. Right? Similar things. Right? This is design rule or engineering principles. So we can collect those pieces of knowledge or rules and make a database. We say rule database or rule base in short. Right? And then similarly, ontology. Ontology. Have you heard about ontology? No. Ontology is, I can say, okay, in this way. Have you heard about semantic web? Semantic web? No? Nobody? All right. Are you using Google? Are you using Google? Search. Google search. Yes? Yes. How long have you been using Google? How many years?
I don't know, maybe
10 years?
10.
10 years? More than 10 years? Right. Can you remember that 10 years ago, the Google search was not so smart as now. If you have some misspelling or missing space or comma, they could not provide a good result. But nowadays, Google is smart enough to provide you, do you mean this way? Right? If you have something wrong, they provide some alternative answers, right? They are clever than 10 years ago, right? Right. Smart. we call this semantic web technology. Second generation web is www, right? Web technology. Semantic web. They use ontology technology. This is a World Wide Web Consortium, right? You already know this World Wide Web Consortium. They use ontology technology to provide semantic web to make them as smart. So there is also their development in World Wide. And expert system is very similar to rule-based system, but approach is different. That almost same one, but the viewpoint is different. Say that in a steel making company, you are all international student. POSCO is famous steel making company in Korea. POSCO. Have you heard about this name? No. Yes. No. Yes. Two of them. Right. A steel making company in Korea. And then there is a person who is managing the furnace. There is iron is melting inside and then produce steels, right? That is simple. Steel making, right? There is a process. But many people are saying how to make the temperature and condition monitoring of furnace is very important for the quality of the steel. Right? Many people are saying the operation condition of the furnace, the big furnace. Right? You need to have a firing using some coal and other material. Right? So they are saying there are big experience and knowledge inside the human knowledge. So say somebody is working for that POSCO 30 years, he is very experienced, but he will retire tomorrow then. What help? There is another generation is 10 years gap, and he's not well experienced. Right? Somebody is happening, sometimes it's happening in other industries. Old generation is lefting, new generation is not well trained yet. So they want to collect and knowledge of the experienced engineer and then make him as a computer system. That is the idea of expert system. So expertise of well-trained, experienced engineer can be captured into the computer data or knowledge base or software. So this is a software system. Trying to mimic, trying to replace the human expert as a computer expert system. Right? So it was very famous in 20 years ago. So we did many work with this. And then in terms of technology, they use many rule-based. Engineering rules, experience coming from the experience and cases. Right? If temperature is going up 1,000 degrees, then you should careful about some quality or something like that. Right? The kind of rule can be collected many times. And there is another software called the knowledge management system. Right? Design methodologies such as quality, deployment, quality function deployment. Famous method. Axiomatic design is famous because of the President Soonhung KAIST, and trees. Have you heard about trees? No. QFD? Yes? And now it comes to the neural network, artificial intelligence. and deep learning, AlphaGo. Have you heard about AlphaGo? AlphaGo. Only one? You don't know about AlphaGo? Oh, okay. TensorFlow. No? Okay. All right, then I should explain a little bit slower. Slower. All right, grading is already announced. So there will be one written exam, midterm exam, and term project will be higher score. And homework, and seminar presentation yourself in the class, and discussion session lead it by yourself, one of you. Class assistant, there are two. They are missing. Inhwan Lee will come on Wednesday, and also Ingyu will come back to next week. They will help us. They may register also as a student too. So there can be at least 4 Korean students. Class home page, I hope so. It is working now. Okay. This one is created last night, so I saw myself this first time by Mr. Inhwan. Inhwan. So that he put his name first. Okay. Right. So every slide and material will be uploaded into this website. Probably before the class, I hope. But at least after the class. Right. And also the videotape will be uploaded to the YouTube, and there will be a link to the video in the later stage. All right, I need to have your email address. I did not check. Yes. 안 갖고 왔네. 종이 한 장만 가져다가 이메일. Actually, I have. 학생들 저거를 받으려고. 예, 이걸 어떻게 되살리나? 아, 오케이. I don't have your email address here. I can see your email address somewhere. In detail. Anyway, we need to collect your email address to send you the materials and website address later. All right. Right. So, student assignment is that now in KAIST also and other universities, there is a change to new teaching and learning system. One of them idea is flipped learning. Flip is reversing, right? Reversing, flip. So they are saying that learning and teaching is different. I'm teaching, you are learning, right? So it's the opposite side. So we should use rather importance goes to the learning rather than teaching. So many people are saying you should reduce my lecture time and increase student involvement. That's why I'm trying to divide the session into 3 sessions of 25 minutes. So that I will cover first session, and then so lecture material will be divided into 2, right? Every time. So half of them is covered myself first, and then half of them covered by yourself. And then there is another student coming for discussion session, right? About that material, hopefully, but including other things. And then videotaped, and then probably twice times of lectures. Because I found that first time it is not good. Many students doing not good. But second time improvement is big. So I hope you can learn from the lecturing twice. Discussion maybe depending on the time availability. Right, term project. TensorFlow, but there can be another options, but I choose to use TensorFlow because it's famous now. Right? There is open source neural network system provided by Google. Right? It's a kind of artificial intelligence and neural network, a kind of neural network system. But it's still growing, right? An open source system. And then I hope you can combine it with your smartphone system to capture big data. Big data. As I said, big data is most important than neural network, actually. Right? But we are learning neural network now in this class and trying to use them. But you should use together with big data. So big data can be captured from your smartphone. That is my hope. I hope each team has 3 students. We'll see that. Probably we may have 9 students, so we can have 3 teams. It is sample ideas, not assigned ones. Right? You can provide your own ideas. So pattern recognition is very popular, well-known technology. Image processing. Fingerprint. You should find out who is it using an image, right? By processing the image of fingerprint, you can identify that is coming from you, right? And voice is similar, right? Voice. That is signals, right? Signals. You can identify who is it, right? Using voice recognition. And then finally, the fortune teller. Have you have a chance to meet a fortune teller before? You see it from the film, right? Usually they meet you, right? See you and talk with you, and then he may ask your birth date and times and other things, right? And then he gives you your future. How can he do that? I guess he uses big data behind him. So you can do that using computer. We'll see that. For the design, you may get signals and data coming from your smartphone, how you use in one day, in week or month. So you use mostly what? Googling or SNS, telephoning, conversation. I don't know. Well, anyway, You can get all the signals coming from your phone usage, and then you can find out your best phone for your own system. Design your own smartphone. It is only one idea. I just provide. You don't need to follow this. Health data coming from smartphone. My smartphone gives you how many times I work in a day. Okay? Every day I can see that I'm trying to. The doctor told me that you should work more than 10,000 work per day, right? So I see this, how much I. So you can provide as a result health training for yourself or advisory, eatery. Another sample can be you can take a picture of your food every meal, right? And collect them and processing them, and then you can find your dietary habit and something like that. And then you can provide yourself good change for your food. And when I was in China last week, there was a keynote speech from Finland, person from Finland. He showed me very nice, interesting video that you can use your smartphone to capture your face, and then if you processing that video tape of your face, you can find the heartbeat rate coming from your face image video. His lecture. He's saying that you can find very small change of color of your face due to heartbeat, pressure, blood pressure, and small change of color can be more red and faint, probably, but I don't know. He's saying small change, but the resolution of a phone camera is enough to analyze that kind of thing. So you can do, if he's true, then you can do many more things. Probably it's not easy for you to do it within Tom project, but anyway, it's one idea. Health data. Or you can do some fortune teller using your faces too. This is for myself. Korea is the biggest country in shipbuilding worldwide, biggest in shipbuilding, but now is tumbling down because of world economy and because of oil price down. So it's very troubled days in. So everybody wants to see next year there is more demand for shipbuilding or not. Right? Can you do that using data? Can you predict the oil price for next year using big data? Well, it is not coming from your smartphone. But anyway, that is some idea you can do. Question? No question. Then we can switch to. Oh, already time is out. Almost. But I want to show you some of them. This is a sample time schedule of class. So today is this, right? But for about 2 weeks time, I will cover all of them, right? But there will be a lecturer, student lecturer, and myself say this one, right? There will be a myself and student lecture at this time, and then discussion led by another student, right? That will be the format of this. And I found that Dr. Hyung-gi Kim of ADD is Agency for Defense Research of Korea. He's got his PhD from KAIST with myself. He knows about TensorFlow. So that I invite him to teach me, teach to you a special lecture on TensorFlow, how to install, how to use, right? So you can start your project. Another lady, Dr. Yunagang, is also working same institute. She knows about how to take out data from your smartphone, right? So she will help you to learn how to take out data from your smartphone. Then it's okay. Then you can start your project, right? That is idea. And then this is lectures. Okay, so there will be a 3 presentation of term project, and then midterm exam is only one written exam, and then classes also. So this will be revised and uploaded in the website, so you don't need to write down. So that is the format of the class. Question? No question. You should raise more questions. All right. I'll just start and then finish. I could not finish up because of time. But I want to. Why I'm trying to design AI and big data Industry 4.0. Have you heard about Industry 4.0? Yes, only one, right? So changes. There is changes. What is it? Industry 4.0? There are many definitions, so still evolving. But it is my understanding and definition. So it's a 4th generation manufacturing or factory. First generation was textile factory of England about 150 years ago. And first factory, they use machine, engine. Engine is made of, first time is made of water power, and then it changed to steam power, right? Second generation was conveyor belt of Ford Motor Company in Detroit. That is start of 20th century, right? 20th century, right? 10 years ago, right? Around 100 years ago. They start to use electric motors in addition to the engine. Third generation is around 1980. So it's 40 years ago, 50 years ago. Right? They start to use computers. So we tell sometimes computer integrated manufacturing, CIM, many times at the time. I was a student at the time, in 1980s. So I learned much about CIM. First generation, probably around first generation, to use computer for engineering something. Now we are saying first generation of factory called smart factory. But still evolving. This one is still evolving. Right. One more slide and no. Okay, one more slide and then we can finish. Right. How many of you have a driver license? Okay. So you know what is this? Everybody knows what it is. Inside the car, driver seat, right? What is this? What gauge is it?
It's a revolution per minute of the engine.
Engine RPM, right? Engine RPM. RPM, right? RPM. 1000 multiplied. So do you know how the range of normal driving RPM? 3,000? Oh, you don't have a license, but you know it. Yes. 2,000, 3,000 is normal range of RPM when you drive. Can be higher, but usually we are working around this. And what is this? Temperature of heating water or cooling water. Right, cooling water. So you start from C and then normal is in the middle, right? If you go in this way, you should stop, right? Speed, right? Speed, kilometer per hour. Fuel gauge, fuel gauge. There are more, but I'm just saying this. Can you tap these numbers during your driving into your notebook? The numbers, RPM, temperature, fuel gauge, and speed. Can you download the numbers into your notebook? Yes or no? Yes. It's not so difficult, probably, right? There can be new cars has some Bluetooth, some connections and USB connections somewhere. But old cars somehow you can tap some wiring somehow. Right? I don't know, but somebody can. Then, so you transfer the information into your notebook, right? As a sequence of numbers as you're driving. 1 hour. How many numbers are coming? It's up to your resolution of selection or writing down, right? Sensing, we call sensing. Frequency, we call a resolution. Say 1 time per second, or 10 times per second, or 1 time per 10 seconds. It's up to you, right? Let's say 1 number per second, right? Each gauge, 4 gauge, only 4 gauge, right? 1 data per second. You already have connection somehow, Bluetooth or somehow. Easy, right? Easy. But the numbers are coming big, right? 1 hour is made of 3,600 seconds. So you already have 3,600 numbers per gauge, and you have a 4 gauge. How about 1 day? How about 1 month? 1 year? It can be big data, right? Big data. But that is digital transformation. And then you can use that numbers as a big database to analyze, to find out pattern of your driving patterns. Insurance companies see that, oh, you're not good driver. You should have a higher payment on insurance. Or something like that. Right? Otherwise, you cannot, you lose numbers every time. Right? You do not record them. Right? You know that there is already information. Right? In old days, 100 years, you don't have such a system to record, keep the data, and then using them. We are trying to do this for your term project. Right? This is a very small change, but it's a big change. Can be a big change. All right. See you next time. Next time, please raise many questions, please. All right?